Gulf of Maine is a world-class wind power resource with great potential, such as location. We connect New England states to the Canadian provinces. We have infrastructure and manufacturing capacity. We offer a skilled workforce, a developed marine industry, and a great place to do business. Our scientific expertise is exemplified by Maine's universities and independent research institutions. Maine possesses the natural resources, the citizen interest, private and public sector ingenuity, and the political will to move ocean-based wind energy forward. We're excited about this opportunity and proud to showcase the energy potential from our ocean resource. The future is here, and in Maine, we're ready to take the reins.
The Gulf of Maine is one of one of the great fishery resources in the world. It's a sea within a sea. About 120 miles offshore is Georges Bank, and so the Gulf of Maine is really like a big bowl with the coast of Nova Scotia, New Brunswick, Maine, New Hampshire, Massachusetts forming one rim, and then Georges Bank the other rim. The coast is complex. There are rivers, there are islands. The tides range from 7 feet to 9.5 or 10 feet until you get down into the very eastern Maine, where they go up to upwards of 20 feet, and then you go down into the Bay of Fundy, and you get world-renowned tides in the Bay of Fundy. So there's a significant tidal resource here. From an energy generation point of view, there are places along the coast, particularly down around Passamaquoddy Bay, and in some of the rivers where, because of this tidal action, you have a huge amount of tidal current.
It has high winds, it has high waves, and it has some of the strongest tidal currents that you can find anywhere in the United States.
In the Gulf of Maine, we have possibly the most sustainable, high-quality winter winds in the Western Hemisphere.
It has basically everything that generates energy in the ocean kind of comes up in spades.
In a relatively small place, there's a very eclectic mix of marine characteristics that allow you to have interesting choices from an ocean energy siting perspective.
Obviously, Maine has a rich maritime heritage, but it's maintained a vibrant waterfront and port infrastructure. Well, in the last couple of years, we've seen an increase in wind turbine component importation into the state. During that time, our terminal operators in the ports have developed a significant expertise in handling that type of cargo. I meet regularly with companies that are involved in the wind turbine industry just so we can coordinate our efforts and our presence. When we join together our resources that include logistics resources, our resources in design and prototyping and testing, our manufacturing resources, in particular our composites manufacturers, and then also our construction capabilities, we do represent a well vertically integrated group of companies that could be viable competitors in this industry.
Bath Iron Works has been around for 120 years. We have done commercial and naval ship construction. Bath Iron Works can do pretty much any part of a project, from the beginning, design and engineering, through construction, integration, test, and lifecycle support. The land level transfer facility is basically our latest upgrade. It enables us to more efficiently construct ships and large modules. Given our experience and capabilities in the marine environment, we're absolutely poised to help Maine become a leader in alternative energy.
If you look at companies such as Bath Iron Works and Chimbro, that's currently building structures here in Brewer, Maine, and floating them, taking them all the way down to Texas. We know how to work in the ocean. This is yet another industry. It's an energy industry that the state of Maine can build its future on.
We have a coastal community that's still working on the ocean extensively. We have a composites industry that's come out of the boat building community up and down the coast that has potential in terms of turbine components and whatnot. We've got a research capability at the University of Maine that's on the cutting edge of composites research. Though we're a small place, we have a very unusual mix of what I think are competitive advantages for ocean wind.
These are jobs that people who have the experience of working on the water can kind of tailor their expertise bring it to bear for our applications.
The Wired grant came in a few years ago, the Workforce Development Grant, and they started the Maine Advanced Technology Center. It's continuing to grow to first, say, train the people who are already within the companies to further their composite training, to get it even more advanced. And now they're reaching out to people who've never been in the industry and beginning to train them. And then another component is the high school vocational schools.
The University of Maine system, particularly Orono, has a phenomenal engineering department. We get a lot of our engineers from Orono, and they also have some advanced composite work, and they're involved in alternative energy. So the combination there, having the research and development team and capability in our university is absolutely valuable.
There's over 500 PhDs on this campus that do research in a variety of fields related to the ocean. The School of Marine Sciences have been studying the Gulf of Maine for over 100 years right now, into various aspects of it.
UMaine has basically been pioneering some of the state-of-the-art composites work. To capture this wind, you really can't do it with these small turbines. They're just not, it's too powerful. You'd actually probably knock them apart. So you need to have the largest turbines that anyone in the world's ever envisioned.
This laboratory was established by the National Science Foundation back in 1996, and we focused on hybrid composite materials. It's combinations of traditional materials and advanced materials for structural applications, for buildings, for bridges, for offshore wind applications, for wind energy, and so on and so forth. We work with companies in Maine and beyond. We have over 300 clients globally that come to us to develop these technologies and take them to the real world and commercialize them. We're about to expand this laboratory with the 20,000 square foot addition. The goal is to focus on large turbine blades for offshore wind applications.
GOMOOS is the Gulf of Maine Ocean Observing System, and it's one of the first and one of the most comprehensive of the so-called integrated ocean observing systems that are kind of sweeping the country. It's a new way of looking at the ocean. Everything's done in real time. It's available to everyone online. We have a really comprehensive suite of instruments that measure oceanographic variables, and this is kind of what's new about the ocean observing system. So we measure surface currents, we measure currents at multiple depths all the way down to near bottom, we measure temperature and salinity, a lot of parameters at a lot of different depths, all in real time at multiple locations in the Gulf of Maine.
For my company in particular, to have the university there is a very good marketing point. That's why one of our bigger customers comes to us, is because we can then partner with the university.
We are a Maine-based developer of technologies and projects that convert the currents in rivers, tidal flows, and oceans into emission-free electricity. The support that we've received here in Maine from the academic community and from the state has just been tremendous. They have helped us implement our whole turbine optimization program. They've done testing in their tank. They've helped us with all the analytics. They've helped us on material selection. So it's been a great resource.
Our goal and our mission is to help the state of Maine get to the future, not just by education, but also leading the Maine in the research and development world.
Renewable energy is a priority for Maine. We're fortunate to count the Gulf of Maine, that connects New England to Canada, as our greatest asset when it comes to ocean energy. Whether it is wave, tidal, or currents, we're well positioned to foster the necessary public-private partnership to support this quickly developing industry, such as our infrastructure and manufacturing capability, our skilled workforce, because it's not only what we produce, but who produces it, and our outstanding scientific and testing expertise. As Commissioner of the Department of Economic and Community Development, I know firsthand that we're in the right place at the right time with the right people and the right commitment to technology and innovation. And I know that Maine is ready to move to the forefront of ocean energy.